Hello and good afternoon. Today we are going to look on the introduction to data analytics. And we say that data analytics is a process of collecting, cleaning, manipulating, analyzing, and interpreting data to extract insights and make informed decisions. So we say that data can be structured. That is likes of spreadsheets, and structured, e.g., the text documents, or semi-structured. Therefore, we are going to look on the most important areas, and I would recommend you to read on other areas that you are not going to cover. So let us proceed to cross-industry standard process for data mining, and we say that. It's all about it's a framework that provides a strategy roadmap for tracking data-driven projects across the various industries. And it always has the some phases or the six phases stages. The first one is business understanding. You have to clarify the business objective and challenges, and then you translate that business goal into data mining objectives. The second one is data understanding, whereby you explore and familiarize yourself with the available data. And therefore, the tasks you may maybe take is to collect and inventory data sources to assess data quality, which is completeness, accuracy, and consistency. And also you look on the description of the data characteristics, whereby it can be distributions or relationships or comparisons. So the third phase is the data preparation, whereby you clean, you pre-process, and also transform data for analysis. And some of the tasks that you can do is to handle the missing values and outliers. You encounter the category of variables, integrate data from different sources, and also you can do the creation of the new features relevant to the analysis. So the fourth phase is modeling, whereby you select and apply the appropriate data mining technique. Remember that you have to choose the best model for your data that you're going to use to do data mining. The fifth one is the evaluation, whereby you assess the performance and relevance of the models. And also the task is to evaluate the model's accuracy and interpretability. So there is the last phase of is the deployment, whereby you implement the findings of the analysis into solutions and recommendations. So you develop the reports, the dashboards, or visualization to communicate the insights, whereby you can also do the integration of the models into operation system or making decision processes. And then you monitor the model performance and update it as it is needed. So we can proceed to benefits of using the cross industry standard process for data mining. Whereby we say the first one is a strategy approach, which provides a roadmap for efficient project execution. The second one, it improves communication, then it reduces risk for failure, and therefore and also the flexibility. Adapting the various data types and projects and industry contexts improves flexibility. So let's look on data models, and we see that data modeling informs creating representations of data and its relationship within a system. And it always are the three key levels of the data models, whereby we look at the conceptual, logical, and physical. And each level serves a different purpose in the process of designing and implementing data based system. So let's look on the conceptual data model, where we say the purpose is to capture the essence of the data in the business friendly way, focusing on the real world objectives and relationships. You know, um, so primary business for the maybe the stakeholders and analysts who need to understand the overall scope and also the functionality of the system. Then the second one is the logical data model, whereby the purpose is to refine uh, the conceptual data model by adding a technical techniques or details about the data structure and organization. So the next one is the last one is a physical data model, whose purpose is to map the logical data model onto a specific database platform, including storage mechanisms and implementation details. You know, so I would recommend that we go straight to data life cycle. And we see that it always refers to a journey that data takes from its initial creation to its eventual destruction. It's a continuous process actually, with several crucial stages, each playing a vital role in ensuring data accuracy, usability, and security. As ever, the first stage is to identify data sources, whereby you identify the data needed, uh, as well as evaluating the data quality. You assess the relevance, accuracy, completeness, and timelines of the potential data sources. And then you consider the legal and the ethical implications at that stage. Then the second stage is modeling data requirement, whereby you define the data structures. You look at their types, attributes, and relationships, which and this ensures consistent data capture and storage. Then you estimate the data volume and velocity, which will help in appropriate storage and processing systems. Then you establish the data security protocol, whereby you implement the measures to protect the data from unauthorized access, modification, or deletion. Then the third stage is obtaining data, whereby you extract data from the chosen sources. So you utilize the tools and techniques to collect data from various sources according for different formats. Then you transform and clean data to address the issues of what? Inconsistencies, missing values, and errors, to ensure data is accurate and conformity. conformity. So the next stage is recording the data, whereby you choose the appropriate storage solution. You select a storage system uh, that can efficiently handle the volume, velocity, and type of data collected. So you have to consider the options like relational databases, data warehouses, or cloud storage. Then the other one is using data for making business decision, whereby you analyze the data, then you apply the data mining, machine learning, and other analytics techniques to extract insights and patterns from the data. Then you visualize the data. You create the reports, dashboards, visualization to communicate insights clearly and effectively to stakeholders. Then you make the informed decisions. That is, you utilize the extracted insights to guide business strategies, optimize operations, and improve decision making. Then the last one, you do the removal of data, that is removing data. So you evaluate data retention needs, whether the data is needed to be retained or not. So you securely delete the data, and then you do the archive for the valuable data. Then let's proceed on the big data. Um, we say that a big data isn't just a buzzword, it is a transformative force reshaping industry. But what exactly is these big beasts? In essence, it is a collection of the data sets so massive and complex that traditional data processing tools struggle to handle them. And let's look on the 5 core characteristics of the big data. That is 5 V's of big data. The first one is volume, whereby you look on the, it's always there. Imagine data being generated by the millions of the social media posts, census readings, and financial transactions daily. So that is a big data sheer size. Then velocity. This is just the speed which the data is created and needs to be processed Then variety. It's that data comes from different shapes and sizes or structures. It can be structured or unstructured or semi-structured. Then velocity it ensures the accuracy and consistency of the first data set, or the data quality. Then the value is extracting a meaningful insight from this data ocean to make informed decision and drive success. So there is a beyond 5 V's, whereby you look the 5 V's of a solid foundation, but there are the complex of the big data that goes deeper. So we have the complexity, real-time nature, privacy concerns, and scalability. If you talk about the scalability, you talk of the infrastructure, and the tools must adapt and grow as data volume explodes. Then you can look on your own time, you can look on the impact of the big data. So the issues of the healthcare, finance, retail, and so on. So I want to